and we will continue with the unsaturated hydrocarbons. As we know, there are two types of hydrocarbons in the chemistry. The first one is the saturated hydrocarbons, that are the alkanes, and the second one is the unsaturated hydrocarbons, can be alkene, alkyne and aromatic hydrocarbons. Let me continue with the unsaturated hydrocarbons. Guys, unsaturated hydrocarbons means hydrocarbons in which not all carbon atoms make 4 bonds, have 4 single bonds. Yeah, it means that at least one of them makes double, or at least one of them makes the triple bond. Yeah, in your compound there must be at least one double or single bond. There won't be any, all of them carbon makes 4 single bonds. So we can call them unsaturated. It means that you can break that bond. Because of that, we can say it's unsaturated. You broke these bonds and you make them saturated. Unsaturated hydrocarbons has one or more double bonds or triple bonds between the carbon atom that I told you there. Carbon atoms can easily form multiple bonds to other carbon atoms, so multiple bonds in organic compounds are common. As you know, the carbon atom can make multiple bonds, double bonds, single bonds, triple bonds. They can make, it's very common. And the first type of hydrocarbon called, guys, alkene. Let me show you the alkene is what, and the property, and how can we write the name of the alkene. The first one is the alkene. Alkene is, or the hydrocarbon, is unsaturated hydrocarbon. It means that it is a double bond. And the formula of alkene and alkane are different. Did you remember the alkane? Alkane is CnH2n plus 2, but alkene is Cn2H2n. So because of their formula, we can easily determine which one is alkene, which one is alkane. Alkene are unsaturated hydrocarbons that contain carbon-carbon double bond, and general formula is this. It means that in your alkene, there must be a double bond. And how can we write the name of the alkene? It's very easy because we use the same way like as alkane. First, also we can use the longest chain. After that, we can we can find the alkyl groups. We can numerate the carbon atom. After that, we can write the name of the compound by using the same way. Example. But very, very important, sorry about that, very, very important. But in the alkene, we finish with the E-N-E, alkene. So because of that, you can understand it's alkene or alkyne. Alkane, sorry. So let me continue with the example. In here, as you see, guys, we have 1, 2, 3, 4 carbon, and there are 2 different groups. There are different alkyl groups are there. The most important information, guys, your straight chain must contain the double bond. Straight chain must contain the double bond. And in your body must contain double bond. Maybe you think that, teacher, why we don't use this straight instead of this straight? Because if you use this straight, it won't contain a double bond, so it won't be true. It will be wrong. Because of that, your straight chain, your body must contain double bonds. So you can count 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So 4. The highest one is 4. So you can use this straight chain. After that, guys, you can find the alkyl group like alkane. These are the alkyl groups. Where can we numerate? In the alkane, we numerate from where the alkyl group close, we can start that side. But in the alkene, you can check the double bond. Where double bond, you can mostly stop from here. If there's the same amount of double bond in the same side, you can check also the alkyl group. Yani first, check the double bond. Second, check the alkyl groups. After you can determine from left or from right, you can start. So in here, as you know, the carbon double bond on the right side, so 1, 2, 3, and 4, you can write here. After, same as the alkane, we can write the name of the structure. And as in second carbon, we have a what? ethyl, so 2-ethyl, trimethyl. Very, very, very important. If you have an alkene, you have to write here the number in your structure. Which carbon makes double bond? If you start from here, 1 makes double bond. If you start from here, also 1. And you won't write 2 here instead of 1. Because the first carbon makes double bond, it means 1 butene. It means that there is an alkene, but in the first carbon there's a double bond. You can determine from this number. And this number gives you information about where double bond is. Where the double bond. Okay guys, I will do more example about it. If you understand, let me continue. Yes, there are different examples. Let me show you. Write the name of the alkene. As we know, guys, it consists of the double bond, so it's alkene. But where can we start? If you find the freedom body, it means a straight chain. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. They are same. So I use this chain like a straight chain, our body. After this is the alkyl group. And if you check the double bond, you will see that double bond is center. If double bond is center, that I told you before, first check the double bond. If it's center, if there is no difference, you can check secondly what? Alkyl group. Alkyl group is close to where? Right side. So you can start from the right side numerate. 1, 2, 3, 4. So if you start from here, the second carbon we have what? 2-methyl. And you have to tell that this is butene, isn't it? Butene, yes, because it's the 4 carbon. But in which carbon makes double bond? 1, 2. So in the second carbon makes double bond. So 2 butene. Don't write 3 because you use the order. And you can start from 1, 2, 3. So second carbon makes double bond after third carbon makes double bond. So that you can write 2 butene. What about that one? In here, if you check that one, the straight double bond here, you can start from here or here, it doesn't matter. If you check, you will see the same number will be there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So they will be same. So because of that, I use this one. It's better for me. So in here we have a 6 carbon. If you check the double bond, you will see in the double bond is center. Both sides they close, same close between both sides. So second say that check the alkyl group. Alkyl group from the left side is closer to the left side. Because of that, you can use from here 1, 2, 3, 4, 5, 6. So in the second carbon we have what? 2-methyl. In the which carbon makes double bond? Third or fourth? Third. 3. 1, 2, 3, 4, 5, 6. It's a hexene. Not hexane, hexene. I think it's easy. Okay, and sometimes they will give you the structure, they will ask you the name, sometimes they will give you the name, they will ask you the structure. It's also very easy. Draw the condensed structure formula for 4-methyl 1,3-pentadiene. Also guys, there was no example about it, but I'll show you the example. If you have in your structure there is a 2 double bond, the name also changed. I will add something to the end of the formula. I will show you that one. Guys, penta. It means we have a 5 carbon. 1, 2, 3, 4, 5. And they say 1,3-pentadiene. It means that when the first and third carbon, there will be a double bond. First carbon, 1, 2, 3, 4, 3. In the second, third carbon, we have a double bond. And the others are single. So it's called pentadiene 1, 3. After 4-methyl, 1, 2, 3, 4, 5. So methyl is where? Here. So 4-methyl here and H2, H, 1, 2, 3, 4 bonds are there, so they are, it doesn't need hydrogen, so CH3. This is the name of the 4-methyl 1,3-pentadiene. Guys, very, very important. How many numbers are there before the alkene? You can write here. Do you remember diethyl? 1,1-diethyl or 1,2,3-triethyl. Depends on the number of the double bond. We can write here di, tri, penta, or hexa. It doesn't depend on the number of the carbon. How many number of the double bonds are there? You can write this amount of here. If 2 double bonds in your structure, di. If you have a three double bonds, you can say, for example, triene. If there's a 4, tetraene, pentene. Okay, like that, guys. That's enough for that. Next lesson, we will continue with the property of the